All right, the second section that we are going to look at today is solving inequalities and graphing them. We're talking about inequalities that just have one variable in them. So when we're solving them and graphing them, we're going to graph them on the number line. This is just solving for x, a one-dimensional problem. All right, the only special thing about solving inequalities that you need to remember is that if you multiply or divide by a negative number, you want to change the direction of the inequality. All right? I want to talk about compound inequalities. Well, before they do that, let me do an example of changing the direction. So say I had this problem, and I divided both sides by -3. I would have x, I would change the direction of the inequality. X is strictly less than -3. I would draw a number line. I would label my numbers. Because it's strictly less than, I want an open circle on 3, and then I want to indicate that I'm shading to the left. Okay. All right, more importantly, I want to review compound inequalities. All right, so there are two kinds of compound inequalities, ORs or ANDs. So an OR problem would look like this. Y minus 3 is greater than 5, or y plus 3 is less than -2. In general, when we're solving an OR problem, the graph usually looks like two arrows pointing out to the side like this, but that necessarily isn't always the case. All right, so I am just going to go ahead and solve these, add 3 to both sides, so I get y is greater than 8, or subtract 3, y is less than -5. Again, this is only one variable, even though it's y's, so we are still just graphing on a number line. So here I have 1, 2, 3, 4, -5 here, 1, 2, 3, 4, 5, 6, 7, 8 here. I'm going to make my number line a little bit longer. So an OR means that either answer would work. So we want all of these answers. Sometimes you'll see that as written like this, the union of both sets. We want all the, it stands for union. We want all the y's greater than 8, open circle, arrow going to the right, and all the y's less than 5, open circle, arrow going to the left. So that would be how I would represent an OR solution set. All right, the other kind is an AND problem, or a compound inequality where there is two inequality signs going in the same direction. So for example, if I have -4 less than 2x minus 8 less than or equal to 10. All right, you can work on this all in one, or you can split it up into two equations. All right, if I were to split it up into two equations, I would split it up as -4 is less than 2x minus 8, and 2x minus 8 is less than or equal to 10. All right, but I'm going to go ahead and solve this just as is. It just means that whatever I do to the middle here, I need to do to each ends. All right, to solve this, so I'm going to add 8 here to get x by itself. So I'm going to add 8 on the left side, and I'm going to add 8 on this side. So I get 4 is less than 2x is less than or equal to 18. All right, I'm going to divide everything by 2. So I get 2 is less than x is less than or equal to 9. Most of the time when you have a compound inequality or an AND, you're going to have two circles and the shading is going to be in between. Occasionally you'll actually shade the whole number line, but in general that's what it looks like. Again, if I solve this problem right here, I would get 2 is less than x, and x is less than or equal to 9. So I would get the same answer. I want to show you though what it looks like on a number line. It would look like, let's start 2, 3, 4, 5, 6, 7, 8, 9. An open circle on 2, a closed circle on 9 because I have less than or equal to, and then shading in between. Okay? All right, hopefully that's all you need to know about compound inequalities. And you can complete your problem set.